Hello YouTube. A viewer contacted me and asked me to do a little video on the rheostats for the ASA adjustment on their camera. That's that part right there. There's only so much I can really do because these things are not serviceable parts. They're stamped together, and as far as I can tell, they're made to never come apart again. I'll go through the motions as best as able with what I do know. So you start out with your camera more or less like this, only not all frigged up. Take the top off, and you get down to where's the parts. And in taking the top off, you're going to remove all of the knob parts for the ASA and the shutter speed adjustment. So it's going to be like that. It'd be like that. So you're going to take all that stuff off, and it's going to be, depending on what model it is, probably 4 pieces: shutter speed, ASA or ISO speed, presser spring, and the cap. That's going to take you down to this. And you take the cover off like that, and it brings you down to this right here. So we get some more light on this. To this right there. Now this rheostat, I'm calling it a rheostat. I don't really know what it's called. It's held down by, let me use my pointer, by 3 screws. And above this is also going to be that thing. But you can get this, it's held down by 3 screws, and you can take those 3 screws out without disturbing any of the mechanics underneath, which is a very good thing because you get down below this plate and things can go sideways pretty quick. So if you're at this point, you've taken this off, and you don't have to worry about losing position, because if you can see in the inner ring, there's a tab, a little space in it that's going to correspond to a tab on the ring you're going to take off. And that tab will fit down into that slot. I know my fingers are in the way, but it's going to fit down something like that. So you don't really have to worry about keeping it in the exact same spot you found it in, because you can adjust it accordingly later. These things, the shutter speed adjustment is either going to be dead on or off a little bit, and it's easy enough to figure out which is which, because between bulb and 1/1000th of a second is a big gap, and you can feel it as you click it around. Anyhow, so if you're at this point, you get your rheostat out. It's got 2 solder joints that you do not want to screw with, and you want to be very gentle handling it. The solder joints are pretty tough, but the little bit of wire, and these are little wires, that little bit of wire at the edge of the solder joint, you flex that a few times, it's going to get metal fatigue and they're going to snap off. And you can solder them back on. It's not terribly hard, but it's unfortunate, and it can be a little nerve-wracking and not a great experience. So having said all that, here we have the actual rheostat unit. I'm going to call it the spinny thing because I don't know what else to call it. It spins freely, full circles. These are 2 different, same camera, 2 different models. They both have 3 solder tabs. Both of them have a solder tab here and here, and I'm not sure, but I think that might be power in. And one of these will be power out. On this one, it happens to be this solder tab. On this one, it happens to be the other solder tab. So I don't really know what the difference is or what they do differently. I assume it's the same thing, only different. Beyond that, I have no clue. I wanted to see a little bit of resistance, so I'm going to get out my fluke. I'll see what we can see. I'll try to keep this in camera. Set it for ohms. Make sure it's working. Good. And then if we take the probes, and on this one, I'm going to put it on this tab, the one that had this. I'm going to zoom in on this. Okay, so this one, I'm going to put the probe, actually because I think this is how it goes. I'm going to put the black probe there and the red probe on this one, because this is how it was wired when it came out. And I'm going to turn the dial. Okay, now I've got the beginning of resistance, turning it counterclockwise, upside down. And as I turn it counterclockwise, resistance increases. I'm turning it about the same way with each touch, and it's gone from mega ohms to kilo ohms. I think that's what it is. I'm not an engineer. When I deal with resistance, it usually has to do just with open or closed circuits. But I see a steady increase and then back down to 0. You're gonna get 0? Oh, no 0. Oh, there's 0. Okay, so that tells me there is no current passing through. Turn it a little bit more. Again, counterclockwise. And we start to get resistance again. Seems pretty consistent. Check the other one. Again, it's upside down. I'm going to go to this solder joint because this is the one that was connected when I removed it from the camera. And again to there. Upside down, turning counterclockwise. This one shows the resistance decreasing. Although this one does not seem consistent. It jumps around quite a bit. So I'm going to say this one probably isn't much good. Or it's filthy. The person that contacted me said that their camera had been pretty filthy when they got it. So I'm going to take that for what it, at face value, just assume the whole camera was filthy. Inside this thing, if you get up real close to it, and you may need, where did I put it? A loop. So you can see there's a gap in between the two plates, and on this soldered tab, this one happens to have a contact that goes inside in between the plates. This one has one that rides on the outside, but this one has one that goes inside against the bottom. This is right side up now. This has, the tab goes and presses against the bottom layer. Now inside there, and you won't be able to see it because it is inside, there's two tabs that ride against the top layer. And somewhere in all that magic stuff is where the resistance happens. Now the only thing these things actually do is they make minor adjustments to the light meter to allow for difference in film speed. Sort of like the distributor on an old car. You turn them one way, it advances the spark. You turn them the other way, it retards the spark. This is doing the same job. It's advancing or retarding the amount of input into the not even computer, the photocells and related parts that regulate the light meter in a camera. That's all it does. It does the same job as shutter and aperture combined, just in much more minor increments. It's actually kind of a redundant thing. Most of my cameras, if the meters work at all, they work badly, so I use a handheld light meter. If you've got one and it's giving you trouble, I think this person said that their meter was jumpy, and turning the shutter speed does not necessarily move this. I've never actually checked that out. I don't know if that does or not. Yeah, I guess it would. Whatever, it doesn't matter. Light meter is jumpy every time this guy touches the shutter speed dial. My guess would be because there's really nothing in here other than copper plates and whatever they use for resistance. Could have a layer of crud in there. I've cleaned up a lot of contactors over the years. You can try getting in there with perhaps a piece of cloth, but you want to be very aware of your contacts that stick in between the plates. You want to know which way they're pointing and whether they're going up or down, because you don't want to bend them or break them or snap them off by sticking anything in there, like a piece of cloth, getting it in there soaked with electrical contact cleaner. Or you could use, this is a shop towel, a paper shop towel. This would probably be my choice. Get a few drops of stuff on it. Note where those contacts are. Slide that thing in there and very gently rub it around. And if you're really dexterous, or you can get a couple extra hands, you could do that and turn this thing while the paper is in there. But there again, you want to make sure you know exactly which direction those contactors are in, so as you're turning it, you don't go against it, because those contacts in there are tiny and they will bend very easily, and then you're left with crap. Probably right off the cuff, I would try taking this off, very gently turning it, and spritzing out the plates with electrical contact cleaner, being careful not to get your guts wet, and give that a try. Maybe spray it, turn it with nothing in it, just spray, turn, spray, turn, and then when you've done that a couple times, take a can of compressed air and then blow out the liquid and give that a try. Beyond that, I really don't know what I could add to it. This is my second video on this. The first one I talked a lot and didn't really say very much that was worth hearing. Beyond that, there's not much. There's not a lot that I can see that can go wrong with this thing. It doesn't have, other than, part of it turns, there's no real moving parts. I doubt it's worn out, although I have seen contacts wear out. And if it's filthy inside, it's gonna create poor contact, which will definitely make the meter jumpy. So that's about all I can really offer you with this one, because there's just not anything to show really. It's not hard to get to. You don't have to take a lot apart. You've got to take off, all the stuff that's on the top of the camera, take out the screws. But once you get the top off, you don't really have to disturb any of the mechanical guts. You can do this relatively safely. You just want to be careful while you're moving stuff. This thing, I've used this one a lot for demonstrator purposes, and it hasn't broken yet, but I've broken a lot of wires just from simple motions. Because bear in mind, these are optimistically 50 years old, and they were probably never meant to last this long in the beginning, but they are built like somebody cared. So you've got that in your favor. So beyond that, I hope you find this helpful, and until next time.